Inertia in object geometry. I will describe the action of inertia on the example of a city bus passenger. The passenger stands on the floor of the bus and holds on to what he can. The bus often brakes or accelerates, creating forces that cause the passenger to accelerate negatively or positively. Negative acceleration acts on the passenger when the bus is braking. A bus with a passenger reduces its speed and energy. Positive acceleration works while accelerating, increasing the speed and energy of the bus and passenger. The passenger feels that his body is subjected to an inertial force that tries to resist the change in speed of the bus. If it accelerates, the force of inertia pushes it in the opposite direction. The bus passenger consists of a huge amount of atoms. Each atom has a nucleus where almost all of its mass is concentrated. This mass is equivalent to the stored energy in the nucleus of an atom. In the further part of the description of inertia, let us adopt the following notations. Let object A be one of the nuclei of the passenger's atoms, which is acted on by an external force F produced by the external object Z, which is the bus. The action of the force F on the passenger is transferred to each of its atoms and objects A through electric and magnetic interactions. These interactions keep the passenger object in one coherent whole. They cause all atoms of the passenger to move in a common direction under the action of an external force F. To describe inertia, we will also need gravity and the related effect, gravitational assist, and consolidation. 1. Gravity is the natural phenomenon that all objects having mass or energy attract each other. Between any pair of bodies having masses, an attractive force appears, and its value depends on the gravitational constant g, the product of their masses, and is inversely proportional to the square of the distance between them. 2. Consolidation is a force generated by the energy stored in the object. Object geometry assumes the energy accumulated in the activities of the possibilities M of the O medium, limited by the boundary conditions of the object, has the property of consolidation. Gravity describes the macro world, for a constant value, gravity constant g. Consolidation is a broader concept. The value of the force generated by it depends on the consolidation coefficient k and the product of the energy accumulated in the objects and inversely proportional to the square of the distance between them. Inside the object, the consolidation force is due to the attraction of the accumulated energy with itself. The consolidation factor k is very strongly dependent on the energy density of the object. For the energy density present in the macro world, the consolidation factor k will be comparable to the value of the gravitational constant g. Consolidation is then the force of gravity. On the other hand, for the energy density in the nucleus, the consolidation factor k is much larger. Consolidation is then a strong interaction. 3. Gravitational assist consists in changing the speed and direction of the spacecraft in the gravitational field of a planet or other large celestial body. This is now a commonly used method of achieving velocities to reach the outer planets of the solar system. It was developed in 1959 at the Moscow Institute of Mathematics named after Steklova. If a spacecraft passes a planet from behind, the gravitational force of the planet increases its energy and velocity relative to the Sunday. If it passes the planet in front, its energy and speed relative to the external object, in this case the Sun, decreases. On the back, it means that the spacecraft catches up with the planet in its orbit and is pulled by it with additional force, at the expense of the planet's energy. In front, it means the spacecraft is catching up with a planet in its orbit. Now the situation is reversed, it is the spacecraft that pulls the planet with additional force, at the cost of its energy. For objects with high energy density, we will use the analogous term consolidation assist. Let us return to the nucleus of the atom. Energy is stored in the nucleus of an atom, equivalent to its mass. Let's divide the energy stored in the nucleus of atom A into n parts. Such one n part, due to the consolidation force from the rest of the energy, moves to the center of the object A and further until it is turned back on its surface, to its center. If the force F does not act on the object A, then the location of the center of the object A in its spacetime does not change for the moving n parts of energy. As a result of the force F, the object nucleus of atom A starts to move with positive or negative acceleration. If the force F acts on object A, I will cause its center in the object's spacetime to change. The moving nth part of the energy will not pass through the center of his spacetime, but next to it. Consolidation assist will work on it. If n part of the energy of an object's nucleus passes in front of the moving center of object A, it will lose its energy. Negative acceleration reduces the energy stored in object A. If n part of the object's energy the nucleus moves behind the moving center of object A, it will increase its energy. Positive acceleration increases the energy stored in object A. In both cases, the consolidation assist applies a force opposite to the direction of force F on object A. Let's go back to the passenger on the bus. If the object Z of the bus accelerates, then each object A of the passenger is subjected to a force F causing its positive acceleration. The consolidation assist increases the energy of object A and creates a force opposite to the force F. If the bus brakes, producing negative acceleration, each passenger object A loses energy and creates a force opposite to F. In both cases, the consolidation assist in the accelerating object A creates a force opposing the force F depending on the type of acceleration produced by the force F. The spacetime of object A looks different. The terms front and back mean the orientation of object A in the direction of its motion. Negative acceleration acts on the spacetime of the object and vice versa, it stretches in front and bends in back. In both cases, the action of the external force F changes the spacetime of the object A. Changing the spacetime of the object A activates the consolidation assist, causing a change in its energy. Finally, I will remind you of the assumptions of object geometry, on the basis of which the description of inertia was created. 1. The object is a spacetime bounded by boundary conditions. 2. There is a common O-center for all objects. 3. The O-center is a set of information about the operation of the M capabilities of all objects, unlimited in space and time. 4. The activities of the possibilities M of the medium O in the spacetime of the object, move at the speed of light. 5. The energy accumulated in the activities of the possibilities M of the O medium, limited by the boundary conditions of the object, has the property of consolidation. 6. An entanglement type object gathers in the O-center information about the operation of the entangled capabilities of M objects. 7. Entanglement limits the operation of an object's M capabilities, as stated in the entanglement instruction. 8. Superposition defines new objects by instructing them to operate on their M capabilities and the energy from the entanglement object. The model of inertia action presented above does not yet have a mathematical description.